Hi everyone, my name is Heather Shapiro. I'm a technical evangelist at Microsoft. And what I'm using today, you'll see it's a speech to text translator. So it's our new Microsoft plugin for PowerPoint that translates text in real time or translates speech in real time. So depending on how far I am to the mic, it may or may not be as correct as you want, but it's still learning. And if you want to go and see what it actually, see it in different languages, you can go to this link, this URL, and it will actually translate in real time, and it will go into different languages. And you can actually, if I turn on the feature, you would be able to interact with me in different languages. So this is something that we're doing at Microsoft for accessibility. That's really awesome. It is more inclusive, so people who aren't hearing or who are part of the deaf community. Also for those who aren't proficient English speakers, it makes it much more inclusive to those in the community. So for today, we're going to talk about, it's called There's a Sign for That. We're going to learn how to convert phrases to sign language GIFs using Python. So it's a pretty primitive model. It's at the beginning stages and need to add a lot more machine learning algorithms to it. But you'll see the way that you can get started. And if anyone in the future wants to collaborate with me on it, that would be great. Perfect. And so I'm learning sign language myself, so I'm not comfortable enough to do it while speaking. But the goal for me is we don't have a big tech community around that is inclusive of the deaf community. So I want to at some point be able to sign my presentations. So this is a start towards that. So what we'll cover, intro to deaf culture and American Sign Language. And since I am still learning about the culture, if anyone has insights that if I make any mistakes, please let me know. I want to be as inclusive as possible. Also use Microsoft Cognitive Services to be able to convert speech to text, and then also take OCR, so take these GIFs, pass them through image recognition, get the text, then do a little machine learning to get the closest phrase that will come out. So one thing to note, deaf people can do anything a hearing person can do except hear. So when you're talking about the deaf community, it's important to recognize that they don't like to be called hearing impaired, because that means that there's something wrong with them. It's better to call it the deaf culture or deaf community. So deaf with a capital D means that they're active in deaf culture, and deaf with a lowercase d means that they have profound hearing loss but not active in deaf culture, which means that they might not use ASL and they're not necessarily involved in the community. Then there's also hearing and hard of hearing as part of deaf culture. So we'll focus on American Sign Language, which is ASL. So if you want to try it, ASL. Yay! Now you all know a little sign language. There's different sign languages for different countries. So there's French Sign Language. Canadians also use American Sign Language, but it differs from language to language. And it's important to note that it is an official language used by people in the deaf culture. And it's not just a shortcut of spoken English. The grammar, there is specific grammar that goes along with it, and there's no written form, and it's not universal, so just to keep that in mind. So when you're referring to sign language, to remember that there's American Sign Language, French Sign Language, and all that. And so it is a language, you've probably seen it, that incorporates mime, picture-like images to express and convey abstract ideas. And there's a lot of facial, you show a lot of emotion in your face, so if you're asking a question, like you're saying what, you're supposed to lower your eyebrows, and there's usually when people do that in the hearing community, people often think that might be weird if you show too many facial expressions, but that's actually a huge part of sign language. So what I'm going to show you today for the code, it's only 25 minutes, so I won't go too deep into it, but if you have questions, I will put it up onto GitHub and post that online, and you can feel free to email me or ask me questions afterwards. But we're going to work with Jupyter Notebooks in Azure. So how many people have used Jupyter Notebooks before? Yay, okay. Has anyone worked with Jupyter Notebooks in Azure? Woohoo! Has anyone seen it before, besides for my talk last year? But you've seen it. Awesome. Okay. So Azure, oh, you can't see it yet. Hold on. Okay. So that I can keep this up. This is also one of my first times trying to have the transcription at the same time, so I apologize if it gets too messy. All right. So Azure Notebooks is essentially Jupyter Notebooks, but online in Azure. All you need to get started is a Microsoft account, so you could have a Live ID if you use Xbox Live, anything like that. You can also connect it to any sort of email that you have. You don't need Azure to get started. So it's a free service, and it runs Jupyter the same way that you would run it locally. So with Azure Notebooks, one cool feature that they have is there's a slideshow presentation feature, which makes it easier. You can code in real time, so I could run this, and it would work depending on Wi-Fi and whatnot. So the important things that we'll have to look at, so we'll need Azure. Then we'll have to look at how to make an HTTP request, because we're going to pull down a Giffy library. So everyone's seen Giffy before? Yes. So actually on Giffy, there's a Sign with Robert Giffy channel. And so this channel has about 1,500 signs. And so my idea here was, how about I pull down all of them, pull down 1,500 of them, or however many there are. And unfortunately, the Giffy API right now doesn't let you pull out the tags, and all the words are in the tags. So I passed them all through our Microsoft Cognitive Service APIs. So our cognitive services are a set of 29, there might be more. There's a bunch in preview, APIs that go through vision, speech. Oh, this is muted. No. Sorry. Has vision, speech, knowledge, search, language. So there's tons of different APIs that you can use to add to your own application. So if you want to do speech to text, or if you want to pass in an image, it makes it a lot easier using these APIs. There's in different languages, there's SDKs already. For Python, a lot of them are you have to make a REST call. So if you want to work on a wrapper, that would be great. Just to help the community. So these you can try for free. There's free tiers. You can do like 5,000 calls a month. So if you're just getting started, and depending on which AI you choose, if you're just getting started, it's a great way to practice with the AIs and add them into your apps. So I pulled down all of the APIs. You can ignore my subscription keys. They'll be gone in a second. Or they'll be gone after this, so it's fine. And they're all free, so you won't be able to get anything from them anyway. So when we want to create HTTP requests, we can look through, we just have to go to this Vision API. I won't go through the code too much. So one thing that I noticed while going through this was that OCR has a hard time with GIFs. And it could be the lighting, the motion, so I had to use the stills. And that still had a hard time for a lot of the images that were passed through. And that could also be lighting, because a lot of them, there's different shading. They're not normal pictures that you would necessarily pass through. So it's something that I will pass along back to the product team and let them know that this is an area that they need to focus on. But I tried to remove all the ones that had errors, and I also passed them through a spell check as well using cognitive services. So I pulled down all the different URLs. It's just code, we won't go through it. And so I didn't have to do it every time. I put it into a CSV so that I could just easily get it, remove all the not applicable ones. And so we get a data frame that looks like this. It has the URL, it has the phrase, and then it has the still URL. So you can see phrases like alcohol, popcorn, wine, sick, something like, here's an example to shoo someone. So this is an example of where OCR kind of got confused. It was to shoo someone away, but it couldn't necessarily understand that. So when we look at the natural language models, we'll have to see, is there a way to make it better in the future to be able to get that? Is there a way when we're passing in the images through OCR to pass in a better image? Is this still the best? Or are there different sizes that would be better? But for the most part, we were able to get over 1,500 of them that actually have words. Are we there yet? Please help me. Different things like that. So to find the closest match, there's a couple of libraries that you can use. So has anyone ever used Fuzzy Wuzzy or difflib? A few people, awesome. So these are pretty common libraries in Python that you can use to find the closest match. So essentially, what I was doing was I have a whole list of all these words, so have phrases, and then I wanted to find, okay, if I put this text in, where's food? Can it figure out that I wanted, where is the food? So this one didn't do the greatest job. But if I look at something like, how are you? It knows the first choice is, how are you doing? So there's different methods that you can use. So Fuzzy Wuzzy uses 11 scene distance, whereas ones like, so if I do this, one thing that you can get is, no, it's not what I needed. Hold on, didn't run it. Yeah, let's see. So where bathroom is what I search for this one, and then we can display the GIF. From passing it in, it goes, all the images are now pulled through OCR, and I can pass in and find the closest value. So if I spell it wrong, it should work. We'll see. No. So so Fuzzy Wuzzy I found actually pulls up, like we saw before, if you have ones that don't match that closely. I don't know why it's called Fuzzy Wuzzy. So the third closest choice was where's bathroom, but he, because it has that exact match of he, comes up first. So going forward, that would be where we can start making the machine learning model even better, making it more intricate and seeing, okay, this is he and her, this is not, there's obviously a lot more letters than that, it's not what I meant to say. Can we get that where's bathroom?
So it was 11 scene distance?
Yes. Yeah, so Fuzzy Wuzzy uses 11 scene. And then there's difflib, which for certain phrases it works well, and then in certain it doesn't. So combining them in a specific way. So if we say where bathroom, you get bathroom, but if you say where's bathroom, you get where's bathroom. So figuring out how can we combine these to make the best model going forward, and I'm definitely open for suggestions. This is something that I want to use to help improve the community, to make it more accessible, so suggestions on how to do this would be great. But like if I put this, it does show where's the bathroom, but if I go back and say, there's that, where's the bathroom? But without the apostrophe, it didn't work. So a lot of these common libraries that we do have aren't giving you the best models, or they're not always giving you the best responses. But it is pretty cool to be able to see, okay, I am now able to find out how do I want to say, where's the bathroom? So if you want to try it, this is bathroom. So it's T for toilet, and then this is bathroom. And then if you want to go where, it's where. So bathroom, where. So one thing that's interesting for sign language, coming from the hearing community, is that we often say, like, where is the bathroom? But when you're going from sign language, you actually say bathroom where. So it's the reverse. So you say the noun and then the verb. So sometimes it does get a little confusing when you're going back and forth, but that's just something to note when you're going forward. All right, so the speech to text part, it was working, and then this morning I found that the service is down. Of course, so the demo god's not with me today for this part, but Cognitive Services does have a speech to text, and they have the translator, as you can see, that's what it's using on the bottom. But I have the code that will allow you to do it when the service goes back up, so I can just show that briefly. We only have a couple of minutes left, and I want to leave time for questions as well. But so the speech to text part, a lot of times people they don't want to just read if it's helpful to have the reading, the visuals as well. So what my goal is here is to be able to have a GUI that I can record in real time, and it will create the GIF at the end. So it will pair all the GIFs together. So there's a translator API that we have. You have to get some tokens for that. Woo. It's not really too integrated of an API request. It's just in Python, it's pretty long unless you want to use the requests. This one was a little bit more verbose, so you can understand what's going on. And then if you want to pass in a WAV file, you have you just have to say like content type audio wave, and every time I recorded, I saved it as a WAV file, passed it in, get that that speech to text, and then I can find the most similar phrase that will go forward from there. Okay. So if anyone wants to try some other phrases, we can see what's in here. Appropriate phrases. What we can get and see how we can compare. Common phrases like, where's the food? What direction is this? So if there's any word that you're dying to know how to sign.
What are you doing tomorrow?
Let's see. So let me go to the other one first so we can see exactly. So we can say tomorrow because I know. So there's one for what's the weather like for tomorrow. There's what are you doing? So there's a few what are you doings, I guess. There's how are you doing, and this one, the text, somehow it couldn't understand the you. But it's able to pick out that this is still pretty close. It's 89% closeness.
Tomorrow?
Let's see. What do we got? So still get what are you doing. So next thing would be to combine them. So now that I have what are you doing and what are you doing tomorrow, I can print out both and you can say, see what they are. So if I do tomorrow, you can see what tomorrow is first. So tomorrow is just like going forward. So what are you doing? He goes very fast, so I would definitely, on your own, if you want to go slow it down. There's also a lot of good apps that I use. One is called Memrise, so if you are familiar with like Duolingo, it's very similar, except Memrise has a sign language course that you can take, and it converts back and forth from text to images. So that's a good way to learn. Okay, and we have a couple minutes. Okay, so main things that we talked about today, I know it was kind of short, so if you have any questions, please let me know. If you have any suggestions on how to make the algorithms better, much appreciated. So we covered an basic intro of like deaf culture, what it is, how to refer to people who are deaf and in the deaf community, how you can pass sign GIFs through OCR. So you can do that with any library that you have. So the Giffy API, you can just search a channel, or you can find random values based on any text you want, and then pass those through OCR. So if you're interested in doing something similar, you can take this code with a different URL that you would want, or a different key phrase that you would want. Then we can find the most similar GIFs for a given phrase, and then speech to text, which unfortunately wasn't working right now, but I will post a demo of that when it is working, and hopefully that will be soon. But if you have any questions or want some resources, my GitHub has a lot of different projects there, and I'll put this up later today. There's also Microsoft accessibility. There's a lot of information there about what Microsoft is doing to be more accessible, how we're hiring to be more accessible, how when we're creating code, how can we be more accessible, what are the standards, things like that. And then also with our translator API, so you can use this translation API. It's free. If you wanted to add it to your PowerPoint, it's just an extension. There's also like Skype translator if you wanted that. So if you're ever in presentations and wanted to be more inclusive to those in the audience, sometimes they don't have to be completely hard of hearing, but sometimes people just like to have the text in front of them, so it's just more inclusive, and it, for those who need it, it makes it easier. Then there's also the Giffy API. If you are interested in that, there's developers.giffy.com. Then there's, if you're interested in doing more with machine learning, Azure Machine Learning, and there's a new Azure Machine Learning workspace that is a desktop version of Azure Machine Learning. And then Channel 9 and MVA, which is our Microsoft Virtual Academy. And if you want to email me, my email is hshapiro@microsoft.com. My Twitter is microheather. And if you want to say thank you, yay, thank you. And that, thank you. And this applause. Questions, yes.
Do you know how this service does with speech to text for different accents? So I've read that sometimes people with varied accents are not picked up as well as people with a standard American accent. And do you know how Microsoft goes about addressing that type of issue when they are creating services?
So a lot of it comes from the data itself. So when they're training the data, they need more diverse people in general who are to get that data from. So that's one way that they're trying to do that, to get better data to create these models from. Also, you personally can create custom speech models if you wanted to going forward. So if it does have a hard time understanding someone's accent, one of my coworkers, she's from Australia, she made a custom speech model of how she says things, and it can now pick it up perfectly. So it takes a little bit of time, so you have to put in at least 100 WAV files of you saying different sayings, but it will then learn from that, and it has that model tuned directly to your accent. And there's tons of there's different languages. It supports 40 different languages, so it is pretty tuned to different accents, but sometimes it is more difficult depending on how fast people speak or how close they are to the microphone. If you're not close to it, then that makes a lot of difference. So they are working on that, and it all comes down to the developers who are making it, how diverse they are, and in general, just if you wanted to create a custom speech model, you can.
Thank you.
Are you considering writing some type of helper library for Fuzzy Wuzzy?
Yes. I like the name, Fuzzy Wuzzy, but yes, I think going forward, that's the goal of making it doesn't necessarily always choose the right ones. So making some sort of wrapper or helper library that will give you that option of how to choose the best one. Is it like, from this example, like he, she always comes up because that's the most, those letters are like very common in all the words or in all the phrases. So how to remove those common phrases. So adding even a library or a helper library that would just remove common phrases from its list.
Oh, like stop words.
Yeah, stop words, yeah. Any other question?
Is there any effort to use this to apply it to something like an app such as Ava that deaf people could use on a daily basis for their interactions with the hearing community?
So that would be my goal down the line. But there are different apps that do already allow that for the deaf community. But something like this, I think, would be very helpful for, especially in the tech community. You don't often have interpreters or people who are signing, so having even just the translator API, you can go onto your phone and look at this and get the text right in front of you. You can get it, if we could add in that sign part as well so that it's more visual, that would make it a lot better going forward as well. So for applications, I'm not sure exactly what the path is, but the end goal is to definitely put these together so that people who don't necessarily who don't necessarily connect most with like reading versus visual, that we can make it accessible to all of them, to all people, yeah.
Yeah, kind of like along those lines, have you like asked deaf people or kind of found out how well like speech to text is recognized versus having an interpreter? Or like what the differences in experience?
So a lot of the people that I've spoken to, they, especially in the tech world, there aren't that many conferences that will interpret. So it's kind of a catch-22 because they don't want to come to conferences because of that. So even having the speech-to-text, there's not a lot of data to be able to say like Oh, I don't know if this is better or not.
I mean, just like in general, like if you asked a deaf person, like, what's the difference in the experience of like having an interpreter versus reading something on a screen?
I personally haven't, but it's a good question. So if anyone has someone that they can ask, yeah. Yeah, personally, this was just a personal project for me of teaching myself how to do sign language, of how to be more inclusive in my talks and like learn more about the different communities that are in tech that are not necessarily or not necessarily given opportunities to come to all of our presentations. Yes.
Do you know of any libraries, or is there an ability to differentiate speakers as far as identifying one speaker versus another when you're translating everything into text?
Yes. So Cognitive Services does have like a speaker recognition API that's part of it. So you would train it on several people's voices, and then you could always be able to you wouldn't, for the most part, be able to differentiate between myself or someone else, and then it would translate that. And then transcribe that as well. Any other questions? Great. Well, thank you very much.